This tutorial covers the final section in Chapter 5, and we're going to use logarithms to solve equations, which we've already done, but we're going to look at some equations that are more complex than the ones we've done so far. But let's start off by looking at one that you already know how to do. So 3 to the power of x equals 20. Well, before I start solving it, let's just think about this. We know that, say for example, 3 squared is 9 and 3 cubed is 27. So we know that our answer should be 2 point something, because that's what we can determine by looking at these two exponential expressions. Alright, so the way we did this is by rewriting this as a log statement. So x is going to be the log base 3 of 20. And then you use your change of base formula, because your calculator can only do common logs. So log 20 divided by log 3. Make sure that when you enter that into your calculator, the calculator always needs parentheses for the argument of the logarithm. Make sure you close the log of 20 before you divide by the log of 3. Okay, I leave it to you to plug that into your calculator and get a decimal approximation. Okay, well, what happens if the equation is a little bit more involved? This one, for example, the exponent isn't simply x, it's 3x plus 4. And although you could use the same technique that we used in the previous example, there's a more commonly used approach. And that is the following. What I'm going to do is take the logarithm of both sides. So the log of 5 to the power of 3x plus 4 should equal the log of 19. And then I'm going to use one of our logarithm properties. The helpful one here is that you can take your exponent, in this case 3x plus 4, and you can park it in front of the log as a factor. So 3x plus 4 times the log of 5 should equal the log of 19. And then we're trying to isolate x. So 3x plus 4 would equal the log of 19 divided by the log of 5. So I just divided both sides by the log of 5. And now I'm pretty close. 3x would equal log 19 over log 5 minus 4. I'm subtracting 4 from both sides. And then the final step would be to divide both sides by 3. And the expression is going to look somewhat involved, but you just need to enter it into your calculator carefully. So all of that divided by 3. And again, I'm going to leave it to you to go ahead and enter that into your calculator and see what you get. Okay? But to summarize, if you have a variable that is in the exponent position and it is more complicated than just x, the preferred method is to take the logarithm of both sides and then use the logarithm property that allows you to bring the exponent down to the front as a factor. And once the variable is no longer in the exponent, you should know how to solve it. Okay, that was pretty brief. Here's your homework. 3 equations to solve, and I will tell you that the last problem involves, well, how do I want to say it? When you end up getting the s squared out of the exponent position, since it's s squared, you'll actually be solving a quadratic, and you should come up with 2 solutions for this last problem. One will be positive and one will be negative. Okay, have that ready for class next time.